Our second lesson in Unit 8 is on parallelograms. Our learning target says I'm going to use properties of parallelograms to solve problems involving angle measures and side lengths. So let's just get with it. I know a lot of you already know what a parallelogram is. You may not know the official definition, so here it is. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's what a parallelogram is. Sometimes you'll see the symbol for it like that. So if we wanted to talk about parallelogram ABCD, you might see it written like that. Sometimes you'll see me write it like this. This is nothing official. This is just my shorthand. Parallelogram. Sometimes that's how I'll write it. But this is typically the symbology you'll see for a parallelogram. Oops, parallelogram. Okay, now we got some theorems. I think there are 1, 2, 3, 4, 5 or 6 maybe. But here we go. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So PQ would be congruent to SR and PS is congruent to QR if I have a quadrilateral that's a parallelogram. All right, theorem number 2. If a quadrilateral is a parallelogram, then its opposite angles are congruent. And you can see that those are marked as congruent in my picture here. Angle Q is congruent to angle S, and angle P is congruent to angle R. Theorem number 3. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So in other words, the measure of angle P plus the measure of angle S equals 180 degrees. And of course the same would be true for angle P and Q. Measure of angle P plus the measure of angle Q equals 180. And of course I could write the rest of the equations for that parallelogram, but consecutive angles are supplementary. All right, and what is this? Theorem number 4 that we're looking at, I believe? Yep. Number 4, if a quadrilateral is a parallelogram, then its diagonals will bisect each other. And you can see how we have that marked. That's not to say that the diagonals are congruent, but the diagonals do bisect each other. So QM is congruent to MS, and PM is congruent to RM. All right. Theorem number 5. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So 3 or more parallel lines. So here we go. We got them right here. These are our parallel lines. And it says if they cut off congruent segments on one transversal, so if I know that AC is congruent to CE, then what I also know is that BD is congruent to DF. All right, so that's it for the theorems. This lesson I think is going to go a lot more quickly than our first lesson did because we're already to our practice problems, so let's just hit it. STUV is a parallelogram. By the definition of parallelogram, what do I know that that means? It means its opposite sides are parallel. Okay, and we're supposed to find TU and WT. Here's TU. Okay, so let's find TU first. What did we learn? Let's back up here. What did we learn in our theorem? Oh, we learned that opposite sides are congruent. So if opposite sides are congruent, that's easy then. TU is 12 because it's opposite SV, which is 12. And WT, what did I learn in my other theorem? I learned that the diagonals bisect each other. So I know VW is congruent to TW or WT, so WT has to be 14 as well. All right, you got to remember these theorems or you're not going to know how to solve these problems. JKLM is a parallelogram. Find the measure of angle L. Well, L is consecutive to angle M. What did we learn in the theorem about consecutive angles? They're supplementary. So the measure of angle L is going to be 180 minus 135, which is going to be 45 degrees. Okay. ABCD is a parallelogram. Find the value of x. Okay, what's the relationship between angles C and A? They're opposite angles, and I know since ABCD is a parallelogram, those opposite angles are congruent. Therefore, their measures are equal. So 9x plus 2 equals 12x minus 34. So negative 3x equals negative 36. So x equals 12. Alrighty. I think that's it. Yeah, no, it didn't ask us what the angles measure, but we could figure it out, couldn't we? This would be 108 plus 2, so each of these would be 110 degrees, which means angles D and B would be how much? 70 degrees. And hopefully when I add all those up, I know from last lesson the sum of those has to be 360, right? Okay, how about this? The measure of angle, oh, it says find the measure of angle D, the value of y, the value of x, and EH. Okay. Ooh, that's a good one. I should save that for you. Why don't you pause right here and work this and come back and I'll have the solution for you. Okay, so I started with y just because that was the first thing that jumped out at me. I know that FG is congruent to ED, so I just set those two equal. 6y minus 9 equals 21, and I get y equals 5. And then I see here that HG is 8, and I know that it has to be congruent to EH because the diagonals of parallelograms bisect each other. So that tells me that EH is 8. And then for X, I had to kind of guess. I think this means that this whole angle here is 50 degrees. Anyway, that's how I worked the problem. I couldn't really figure out another way to do it. So I know that this angle, which is 50, plus this angle down here, which is 7x plus 4, are supplementary because of the theorem. So I said the sum of those measures is 180, and then when I solved for x, I got 18 degrees. All right, let's see what else we got. Oh, we just have one more problem and a proof. So let's see, find the links to the diagonals in parallelogram KLMN. Ooh, this is a good one. Okay, so what do I know? I know that KP is congruent to MP, and I know that LP is congruent to NP because of the theorem that says the diagonals bisect each other. Therefore, I know their measures are equal. So I know that y plus 10 equals 2x minus 8, and I know that x equals y plus 2. Right? I just set the two parts of the diagonals equal to each other that are congruent. Okay, interesting. What can I do? I have a system of equations, right? I have a system of equations. This one down here is already solved for x, so why don't I use substitution? Why don't I take this, x equals this, and plug it in right there for x, and then I can solve for y, right? Let's do that. Y plus 10 equals 2 times y plus 2 minus 8. Okay, so y plus 10 is 2y, and that'll be plus 4 minus 8, so that's minus 4. So let's see, let's get that 4 on the left. That'll be 14. Subtract y from both sides, and that'll be that. So y is 14. So now I can just plug this 14 right back up into this equation, and I'll have x, right? X equals y plus 2. So x equals 14 plus 2. That means x equals 16. So let's see if that makes sense. If I plug 16 in right here, I get 32. 32 minus 8 is 24. If I put 14 right here, I got 24 equals 24. And if x is 16 and y is 14, yep. So I check both of those and that definitely works. Okay, now we got a proof. And we're proving one of the theorems. We're proving the theorem that says opposite sides of a parallelogram are congruent. So we can't use that theorem. Okay, been a little while since we've written a proof. Boy, I've missed it and I know you have too. Statements, reasons, and of course we're going to put our given statements first. I have parallelogram A, B, C, D, and that's given. Okay, let's see what we can do next. Let me think. What do I know about parallelograms? Oh, well, I know the opposite sides are parallel, right? So I'm going to write that down. That may not be the right next step, but that's where I think I need to go. So AB is parallel to CD, and BC is parallel to AD. And how do I know that? I know that by the definition of parallelogram. Parallelogram is a quadrilateral with opposite sides parallel. Okay, so how does that help me? You know what led me to say that is because of the fact that they numbered these angles. They numbered these angles, so I was thinking, I need to use these angles somehow. Well, how can I use these angles? Oh, if I say my sides, my opposite sides are parallel, then I can start talking about these angles. So let's see what we know about these angles now. Let's look at angle 1. Angle 1 right here is made with side BA and this transversal, and angle 4 is made with CD and that same transversal. So since BA or AB is parallel to CD, get these marked, then I can say that angle 1 is congruent to angle 4, right? Because what kind of angles are there? They're opposite interior angles, but I have the same scenario with angles 2 and 3, right? So I can say angle 2 is congruent to angle 3, and both of those are because of the alternate interior angles theorem. Okay, so that's congruent to that. That's congruent to that. So now what I'm trying to do, guys, is I'm trying to get those two triangles to be congruent to one another, and then I can say that those sides or those segments that I'm trying to prove are corresponding parts of congruent triangles. So think about it. I'm going to leave it with you right here. What do I need to do further to be able to say that triangle ABC is congruent to triangle CDA? So I'm going to leave it with you right there, and you solve this proof, and then you come back and check your answer. All right, there we go. So the only remaining thing we needed to do after we got that our angles were congruent was to say that this shared side here, and if I go around this way, triangle ABC, then what I said is side CA is congruent to, if I go this way in triangle CDA, then I come back that way. So I have to be very careful. We haven't done that in a little while, so be careful. We got to say that side CA is congruent to AC by the symmetric property of congruence. And then I can say that my triangles are congruent by side angle side, and finally those opposite sides of the parallelogram are congruent because they're corresponding parts of congruent triangles. All right, don't forget your essential question and your summary, and we'll see you next time.